Hi there, this video is going to cover how to simplify expressions with exponents when I include a negative. So to go ahead and get started, I just would like to say that when I deal with exponents, I kind of make a little story for myself. I kind of like to imagine we're at war, and if I have a fraction, there's two sides battling against each other. If there's no fraction, there are forces combining. So as I look at this problem right here, I notice that there's a negative exponent. In my little scenario, negative exponents are like traitors or secret spies. Is to do the following. I would take this expression and I'd say, well, the number or the factor that belongs where it should is the y to the 15th, because it's positive. Because of this negative exponent, it's not where it should be. It should be on the other side of my fraction, on the other side of the battle. So it's going to move to the bottom part of this imaginary fraction that this is under, and I'm going to have y to the third power in the denominator. When I'm looking at a fraction, the top part of the fraction is fighting against the bottom part of the fraction, and because the y's are the same, those are the people that go to war. So if there's 15 y's and on top and 3 y's on bottom and 15 on top, they're going to go to battle. The 3 from the denominator are going to go away, and I'm going to be left with, well, what's 15 minus 3? 12. So y to the 12th power is remaining. So let's look at a similar example. So in this example, the negative exponent is on the wrong side. It needs to join forces with its true alliance. So it moves up to the top. I'm going to rewrite it. Fraction x to the 4th, x to the 6th. Now, since there's nothing remaining in the bottom, I write a 1. When I simplify, that's going to go away. So now that they are part of the same force, I combine anything that has the same base. So I have 4 x's and 6 x's, and that combines to give me 10 x's. So x to the 10th, and then the divided by 1 disappears as part of my simplifying process. Let's look at another one. So if I look at this expression right here, unhappy traitor moves back to where its true alliance belongs. X to the 4th, x to the 2nd. Now, because there's nothing remaining, because there's nothing remaining on the top, I replace it with a 1. Part of my simplifying process, when I have a fraction, I need something on top. I don't always need the denominator like I didn't need it on this problem up here, but I do need to keep the 1 up top. And I combine my denominator. X to the 4th and x to the 2nd, if they join forces, there's 1, 2, 3, 4, 5, 6. X to the 6th power, and this would be my final answer. Okay, so what do I do when there's more than one variable? Well, when there's more than one variable, I'm going to first return the traitor back to the side that they belong on. So I'm going to return b squared up top, and I'm going to rewrite my fraction. So here we go, rewriting my fraction. A to the 4th, b to the 7th, b to the 2nd, and a to the 9th remains on bottom because they're not traitorous. As I simplify this, remember you can only combine and simplify terms that are like. So I would combine the b's together, 2 right here and 7 right here make a total of 9. So as I write my final answer, I have b to the 9th, a to the 4th, a to the 9th. Oh, I forgot to do one round of simplifying. Because I have a fraction, my fractions at war, the top and the bottom, if they're the same variables, go to war. So a doesn't go to war with b, a has to go to war with a. If there's 4 on top and 9 on bottom, all 4 of these a's are going to cancel out, and 4 out of those 9 are going to cancel out, leaving me with 5. So my final answer is b to the 9th over a to the 5th. And that would be my final answer. Alright, let's look at 2 more. So what do I do when I have a power rule and a negative exponent? Well, the first thing I do with the negative exponent is, because it's around parentheses, I would like to assign everyone who's a trader, and everyone who's inside of that parentheses is a trader, and I'm going to assign them their exponent. So 3 to the negative 2, x to the, now remember I'm multiplying. When I put the exponent inside, I'm repeating how many I have. So x to the negative 8th and y to the negative 14th. Well, you notice these are all traders. So here's my imaginary fraction line, and everything's going to go to the denominator. So my new fraction remains 1, 3 to the second. Notice my negative exponent continues to disappear. 8 to the x and y to the 14th. And the only other thing I need to do is simplify. I can simplify 3 to the second power. I know what that is. So 9, x to the 8th power, and y to the 14th power. All right, let's look at our last example. Similar to some of the others, I am multiplying these two fractions together. So my first step is always going to be to make one expression before I start moving things. So when I multiply, I'm going to put things in order. I'm going to put constants first. 3 times a, so there's my a, times, I've got another a squared, times b to the 3rd power, and that's everything in the numerator, divided by 6 times, I'm going to go alphabetical, a to the 9th times b to the negative 2nd. Now it doesn't matter if you are alphabetical, but I find it helps me kind of organize my fraction. Now that everything is together, I'm going to move the traders. This negative 2 in the denominator goes up to the top. Let's rewrite our fraction. 3a times a squared times b cubed times b squared, 6 times a to the 9th. Now that I have simplified and moved my traders, I'm going to simplify each part of my fraction. So I'm going to ignore the bottom, and I'm going to simplify the top. So 3, there's nothing to simplify with a 3, times a squared. Now remember, if there's not one listed, the exponent is a 1. So when I combine these, I end up with a to the 3rd power, b to the 5th power, divided by 6 times a to the 9th power. Now, if you think you're done, double check. Make sure that your fraction doesn't need to go to war. There's nothing for b to go to war with, but the a's, I have to go to battle. All 3 of the a's on top are going to disappear. That's going to cancel out 3 of the a's from the denominator, so b doesn't go to battle, it stays on top. A's shrinks down to a force of 6. Now, be careful with your fraction. I'm going to split 6 into 2 factors, 2 times 3, and because the same factors on top and bottom, I can cancel those out. So 3's gone off the top, part of the 6 has gone off the bottom, and I'm left with a 2. And this would be my final answer. Alright, that is simplifying properties of exponents that include negatives. If you have any questions, please reach out to your teacher.